The ankle, or the talocrural region, is the region where the foot and the leg meet. The ankle includes three joints: the ankle joint proper or talocrural joint, the subtalar joint, and the inferior tibiofibular joint. The movements produced at this joint are dorsiflexion and plantarflexion of the foot. In common usage, the term ankle refers exclusively to the ankle region. In medical terminology, ankle can refer broadly to the region or specifically to the talocrural joint. The main bones of the ankle region are the talus, and the tibia and fibula. The talus is also called the ankle bone. The talocrural joint is a synovial hinge joint that connects the distal ends of the tibia and fibula in the lower limb with the proximal end of the talus. The articulation between the tibia and the talus bears more weight than that between the smaller fibula and the talus. Structure: bones. The bony architecture of the ankle consists of three bones: the tibia, the fibula, and the talus. The articular surface of the tibia is referred to as the plafond. The medial malleolus is a bony process extending distally off the medial tibia. The distal-most aspect of the fibula is called the lateral malleolus. Together, the malleoli, along with their supporting ligaments, stabilize the talus underneath the tibia. The bony arch formed by the tibial plafond and the two malleoli is referred to as the ankle mortise. The mortise is a rectangular socket. The ankle is composed of three joints: the talocrural joint, the subtalar joint, and the inferior tibiofibular joint. The joint surface of all bones in the ankle are covered with articular cartilage. Ligaments: the ankle joint is bound by the strong deltoid ligament and three lateral ligaments: the anterior talofibular ligament, the posterior talofibular ligament, and the calcaneofibular ligament. The deltoid ligament supports the medial side of the joint, and is attached at the medial malleolus of the tibia and connect in four places to the sustentaculum tali of the calcaneus, calcaneonavicular ligament, the navicular tuberosity, and to the medial surface of the talus. The anterior and posterior talofibular ligament support the lateral side of the joint from the lateral malleolus of the fibula to the dorsal and ventral ends of the talus. The calcaneofibular ligament is attached to the lateral malleolus and to the lateral surface of the calcaneus. Though it does not span across the ankle joint itself, the syngysmotic ligament makes an important contribution to the stability of the ankle. This ligament spans the syndesmosis, which is the term for the articulation between the medial aspect of the distal fibula and the lateral aspect of the distal tibia. An isolated injury to this ligament is often called a high ankle sprain. The bony architecture of the ankle joint is most stable in dorsiflexion. Thus, a sprained ankle is more likely to occur when the ankle is plantar flexed, as ligamentous support is more important in this position. The classic ankle sprain involves the anterior talofibular ligament, which is also the most commonly injured ligament during inversion sprains. Another ligament that can be injured in a severe ankle sprain is the calcaneofibular ligament. Mechanoreceptors of the ankle send proprioceptive, sensory input to the central nervous system. Muscle spindles are thought to be the main type of mechanoreceptor responsible for proprioceptive attributes from the ankle. The muscle spindle gives feedback to the CNS system on the current length of the muscle it innervates and to any change in length that occurs. It was hypothesized that muscle spindle feedback from the ankle dorsiflexors played the most substantial role in proprioception relative to other muscular receptors that cross at the ankle joint. However, due to the multiplanar range of motion at the ankle joint, there is not one group of muscles that is responsible for this. This helps to explain the relationship between the ankle and balance. In 2011, a relationship between proprioception of the ankle and balance performance was seen in the CNS. This was done by using the fMRI machine in order to see the changes in brain activity when the receptors of the ankle are stimulated. This implicates the ankle directly with the ability to balance. Further research is needed in order to see to what extent does the ankle affect balance. Evolution. It has been suggested that dexterous control of toes has been lost in favor of a more precise voluntary control of the ankle joint. Clinical relevance. Fractures. Symptoms of an ankle fracture can be similar to those of ankle sprains, though typically they are often more severe by comparison. It is exceedingly rare for the ankle joint to dislocate in the presence of ligamentous injury alone. The talus is most commonly fractured by two methods. The first is hyperdorsiflexion, where the neck of the talus is forced against the tibia and fractures. The second is jumping from a height. The body is fractured as the talus transmits the force from the foot to the lower limb bones. In the setting of an ankle fracture, the talus can become unstable and subluxate or dislocate. People may complain of ecchymosis, or there may be an abnormal position, abnormal motion, or lack of motion. Diagnosis is typically by X-ray. Treatment is either via surgery or casting depending on the fracture types. History: the word ankle or ankle is common, in various forms, to Germanic languages, probably connected in origin with the Latin angulus, or Greek I plus or minus I cubed I, meaning bent. Footnotes: A.B. Moray L. Pages 510, A.B. Ankle at E-Medicine Dictionary, A.B. Brent K. Milner, Ryan S. Fajardo Musculoskeletal Imaging, in Spencer B. Gay Radiology Recall pages 294, A.B. Gregory S. Colt, Lynn Snyder Macular Physical Therapies in Sport and Exercise pages 420-1, A.B. James G. Adams, Eric D. Barton, Jamie Collins Emergency Medicine, Expert Consult pages 2660, A.B. Moray L. pages 521-2, Ankle plus Joint at E-Medicine Dictionary, Michelson J.D., Hutchins C. Mechanoreceptors in Human Ankle Ligaments. The Journal of Bone and Joint Surgery 77, 219-224, Lafayette S.M., Pinsivero Dam, Rossi S.L. Proprioception of the ankle and knee. SportsMed 25. 3, 149-155, Ribot Siska E., Bergenheim M., Albert F., Roll J. Proprioceptive population coding of limb position in humans. Experimental Brain Research. 149. 5, 512-519, Goebel D.J., Coxon J.P., Van Impe, Kutz M., Dwomers M., Wendierath N., Swinnen S.P. Brain activity during ankle proprioceptive stimulation predicts balance performance in young and older adults. The Journal of Neuroscience 31. 45, 16344-16352, Brewer, B. Ashby, P. Corticospinal projections to lower limb motor neurons in man. EXP Brain Res 89, 649 Euro 54 doi, 10.1007/BF00229889. PMIDA 1644127 http, teachmeanatomy.info, references, Anderson, Stephen A. Calais Germain, Blandine. Anatomy of Movement. Chicago, Eastland Press. ISBN A0-939616-17-3 McKinley, Michael P. Martini, Frederick. Timmons, Michael J. Human Anatomy. Englewood Cliffs, New Jersey, Prentice Hall. ISBN A0-13-010011-0. Marie, Elaine Nickpan. Essentials of Human Anatomy and Physiology. San Francisco, Benjamin Cummings. ISBN A0-8053-4940-5. Moore, Keith L. al. Chapter 5, Lower Limb, Overview of Lower Limb. Clinically Oriented Anatomy PPA 509 Euro 669 Additional images. See also, this article uses anatomical terminology. For an overview, see anatomical terminology. Media related to ankle at Wikimedia Commons, foot, leg, external links, the ankle. University of Glasgow 2007. Retrieved March 2010. Ardizone, Remy. Valmarsi, Ronald L., How to Diagnose Lateral Ankle Injuries. Podiatry Today. Retrieved March 2010. Haddad, Stephen L. Foot and Ankle. Your Orthopedic Connection. Archived from the original on March 23, 2010. Retrieved March 2010. A.